So today we'll be learning about Clemmenson reduction. First of all, what is this Clemmenson reduction? This is particularly effective in alkyl aryl ketone reduction in Friedel-Crafts acylation. What is this Friedel-Crafts acylation? When benzene reacts with acyl chloride or acetic anhydride in the presence of Lewis acid FeCl3 or AlCl3, the products will be acetophenone plus HCl or CH3COOH plus AlCl3 or FeCl3, whatever it is. So these will be the products. Acetophenone is the main product. So in Clemmenson reduction, this acetophenone will be acting as the reactant here. So the reduction of acetophenone in the presence of zinc amalgam in acidic conditions, which gives us alkane, is called as Clemmenson reduction. So let us write the general equation first. We'll directly take pH. Okay. pH C double bond O CH3. This is acetophenone. When it reacts with zinc amalgam in acidic conditions, it gives us alkane, which is ethyl benzene. So this is called as Clemmenson reduction. We'll see the mechanism for this equation. First we'll be taking acetophenone, pH C double bond O CH3. Oxygen here has 2 lone pairs. Now first we'll be adding HCl. We have taken HCl right in acidic conditions. So from HCl, the H plus will be reacting with acetophenone, where oxygen will share its lone pair of electrons with this H plus and will give us a product like this, where bond is formed between oxygen and hydrogen. Oxygen gets a positive charge because it is forming 3 bonds. Now as oxygen is getting a positive charge, it will take the bond from carbon and this carbon will be positively charged. CH3 OH, carbon here gets a positive charge. Again oxygen will be having 2 lone pairs. Now what happens here? This compound will react with the zinc. And in this reaction especially, we will be seeing single electron transfer reactions. SET, single electron transfer. So what happens here? Zinc will share one of its electrons with this carbon and will form a bond with the carbon, and zinc gets a positive charge. Okay. Now we have taken H plus from HCl here, and this Cl minus will react here with this compound and will attack this positively charged zinc and will give us a compound like this, pH COH. This will be CH3 itself. Okay, CH3 ZnCl. Now again we will be taking HCl. Okay, where from HCl the H plus will react with this oxygen. Okay, how will it react? Oxygen will share its lone pair of electrons with H plus and will give us a compound like this, OH. As oxygen is carrying 3 bonds, it will get a positive charge. As oxygen is positively charged, what will it do? It will take the bond from carbon and this carbon will be positively charged. And here we will be losing water molecule H2O, minus H2O. pH, carbon here gets a positive charge CH3 ZnCl. So now again with this compound we will be reacting zinc. We will see single electron transfer here also. This zinc will transfer one of its electron to this chlorine, and this bond between zinc and chlorine is taken by zinc and will give us pH, carbon positively charged here, CH3, zinc will be getting a negative charge. This zinc and chlorine, they will be eliminated as ZnCl plus. And here from this HCl we have already taken H plus and reacted with this compound. Now this Cl minus here will react with this ZnCl plus. Okay, that Cl minus will react with this ZnCl plus and will be eliminated as ZnCl2. Okay, here itself it will be eliminated, and this will be the product after this reaction. Then what happens, as this carbon is positively charged, zinc will share its pair of electrons here, and we will be getting a double bond between zinc and carbon. Okay, now what happens here, this carbon will take the bond from zinc and the carbon will get a negative charge. Zinc will be getting a positive charge. Now we will be taking HCl. From HCl, the H plus will form bond with this negatively charged carbon. Cl minus will form bond with the Zn plus and will give us a compound like this, ZnCl. Now again what happens, this carbon will take the bond from zinc, and the carbon here will be getting a negative charge. Okay, hydrogen, and this zinc, it will be eliminated as ZnCl plus. Okay, we will be taking HCl again, it will be eliminated as ZnCl plus. Again we will take HCl, where this H plus will form bond with the carbon here which is negatively charged, and this Cl minus will be eliminated as Cl minus. The Cl will be eliminated as Cl minus and will attack on this positively charged zinc, and the compound will be eliminated as ZnCl2 salt. Now this hydrogen and carbon will form a bond and will give us our final product. This is an alkane. Its name is ethyl benzene. So this is the mechanism for Clemmenson reduction. So these are few examples where we will be seeing Clemmenson reduction. In the first example, this is benzaldehyde. Here this carbonyl group will be reduced to alkane. So what will be the product? We have to follow the same mechanism. Okay. So instead of one double bond, we will be forming two single bonds with the hydrogen, and we will be getting toluene or methyl benzene. Okay. Now this is the second example. Its name is 4-hydroxy 3-methoxybenzaldehyde. Okay, even here we will be seeing Clemmenson reduction. So what will happen here? This carbonyl group, it will be reduced to alkene. OH, OCH3 methoxy group, and here we will be getting one CH3 methyl group. So what will be its name? 1-hydroxy 2-methoxy 4-methyl benzene. So this is what Clemmenson reduction is.